Welcome to qnawire.
Okay, problem 69. We're given two values for the rate constant, and those are at different temperatures, which I'm just going to give. And we're asked to calculate the activation energy and the rate constant at 425 Kelvin. Okay, so what I have right here is the equation, the Arrhenius equation in 2-point form. Okay, so this is just a different arrangement of the Arrhenius equation. Okay, so this K right here, this first K is at 400 Kelvin, and the second K is at 450 Kelvin. Okay, and we're asked to find the K for 425 Kelvin. Okay, so the assignment of which one's K1, which one's K2 is pretty much arbitrary. So you could choose either one. So in my case, I'll just choose this first K to be K1 and the second K to be K2. And of course, the temperatures would follow. Okay. And since we're looking for EA first, right? I want to go ahead and isolate it on the left side. So I'll have EA equals, I got ln of K1 over K2, and I'm multiplying that by R and dividing it by 1 over T1 minus 1 over T2. Okay, so the way I rearranged this is that I just multiplied this R to this side, and I divided this whole term right here, okay, in order to isolate EA on one side. Let me remove all that clutter. Okay, so now that we have it all arranged, at this point, we're really just plugging in numbers, right? So I got ln of K1, I said would be 0.0117 per second over K2, which is 0.689 per second. And I'm multiplying R, and I want to express it as kilojoules, so I'm using 8.314 times 10 to the minus 3 kilojoules per mole Kelvin. And all of that over 1 over T1, which is 400 Kelvin, minus 1 over 450 Kelvin for T2, right? Okay, so now all we need to do is plug in those numbers in a calculator, right? So let me plug that in, and that should give us 122. So EA equals 122 kilojoules per mole. Okay, so that's part A, and I made our screen smaller here just to make sure we have enough space. Okay, so for part B, we're looking for the rate constant at 425K, and we're pretty much just going to use the same equation. It's just that this time we're looking for one of the rate constants, since we already have the activation energy from part A, right? So again, all the assignments of K and temperature here is arbitrary. So for part B, I'm just going to choose this K2 as the information, right? So you'll see what I mean as we go. Let me rewrite that equation. I have ln K1 over K2 equals EA over R 1 over T1 minus 1 over T2. Okay, so I'm calling this as K2 still. So I have my K2, right? I have my EA, I have my temperatures as well. So what I want to do at this point is just to isolate that K1, right? So in order to do that, we need to raise both sides by E, right? In order to cancel that ln, okay? So now I have K1 over K2 equals E raised to EA over R 1 over T1 minus 1 over T2, okay? So you could have plugged in numbers before you rearrange the whole thing, but I prefer just dealing with the variables before plugging in the numbers, okay? So now I have K1 over K2 on the left side, and I only want K1 on that right side. Or, sorry, I only want K1 on the left side. So what I'm going to do here is multiply K2 on both sides, right? So I'm going to have K2 multiplied here, okay? And that K2 is going to disappear once I multiply this by K2, right? So let me just erase everything I have on the left side, and I only have K1 now, okay? So at this point, we just plug in numbers, right? So we got E raised to, I know EA is 122 kilojoules per mole according to part A, and R is, since this is in kilojoules, I want to express my R in kilojoules as well, 8.314 times 10 to the minus 3 kilojoules per mole Kelvin. Okay, oops, I'm not done yet. We need to multiply that by 1 over T1. Since we're looking for K1, that means T1 is 425 Kelvin. Right, so as I said, the assignment is of the numbers is arbitrary as long as you make sure they match, okay? So we're looking for K1, meaning T1 would be 425 Kelvin. 1 over T2 would be 450 Kelvin. And then K2 is 0.689. I'm running out of space here, but 0.689 per second, okay? Alright, so now we have so many numbers, but the good part about this is that all we need to do is plug this into a calculator, and that should be able to give us our final answer for number 69. Okay, so that whole fiasco of numbers ends up being 0.101 per second. So this is a 0. Okay, and that should be our rate constant at 425 Kelvin.